Welcome to the STEM Education 2020 Speaker Series. It's my pleasure to introduce Dr. Jessie Kastler, who's joining us from the Marine Education Center in Ocean Springs, Mississippi, here at USM, just on our other campus. So please welcome Jessie. Hi guys, thank you for coming. Thank you for being online. I am going to talk about science that hits close to home and how you can, well, I'll tell you what I'm going to talk about as I go. I work at the Marine Education Center. I'm an informal science educator. I've been here at University of Southern Mississippi with the Marine Education Center for almost 13 years. And the Marine Education Center is known for engaging students in outdoor learning. And this is one of our more engaging programs. We got sharks. So I'm just going to jump right into the part that I do. Forget that. I work on communicating science to other audiences. As with some of the K-12 work, it is free choice learning. People don't have to come. We have to have a reason for them. We have to make a reason for them to come. And sometimes it's charismatic megafauna, as with the sharks, but sometimes it's something else. And on the Gulf Coast in the past 15 years, we've had some pretty significant natural and human-made disasters, starting in 2005 with Hurricane Katrina, which completely wiped out the Marine Education Center where I work. And we have a new facility that was just finished 2 or so years ago, so it takes a while to come back from that. Subsequently, in 2010, the Deepwater Horizon oil rig blew up on April 20th, so we're hitting that 10-year anniversary. 11 people were killed, and 210 million gallons of oil were distributed into the Gulf of Mexico. It was a big deal, a really, really big deal. There's an awful lot of implications for what's happened in science in the Gulf of Mexico since then. That's not what I'm talking about. I am talking about the relationship to members of the public, of what's going on and what science can contribute. Because the members of the public had a lot of immediate questions. For example, where's the oil going? What's going to happen to it? How does it change along the way? What does it do to things along the way? What happens to the animals? And is it safe to eat the seafood? Scientists tried to explain this, but scientists are not necessarily at their best when somebody puts a microphone in their face, because scientists are trained to say, I don't know, but, and then offer whatever they have to say that's related to the subject. And sometimes that results in messages that are not real specific, not on point, and don't address these particular questions. What's interesting is that these questions remain after 10 years, although we do have some of the answers for them. But these are persistent questions, and it's not easy at all to address them to the satisfaction of the members of the public. Should I get?
I think so.
Okay.
Trying to clear.
Just tell me if I should stop talking.
You're doing great. They couldn't see the video really clear. They can hear you perfectly. So
Okay,
hopefully
that's
they can
fine.
see the
That's
video a
fine.
little bit. Sorry for all the movement.
Okay. So people were looking for conclusive information. They're not really getting it because we don't have it. Science is a work in progress. So people don't trust science. Science is not something people understand, and trust in science is very closely related to science literacy. So how do we make people more scientifically literate? That's going to be what it takes to get people to trust science. And one of the things that we have in our arsenal, our toolkit, is citizen science. Citizen science, right? There we go, wrong direction. Don't touch it. Okay, citizen science is public participation in the process of science. So members of the public work with scientists, and they produce data, and sometimes they participate in various aspects of analyzing the data as well. That's citizen science. That is also a work in progress. It's relatively new that it's become a large thing, but it increases the capacity of scientists to do their work. So we can get more data. More data means more scientific results if there are scientists there to analyze the data. and it can increase science literacy. So that's what I'll be talking about. I have several projects that I've done that have involved citizen science at various, excellent, thank you. I can see y'all now.
And they can choose what screen
Okay,
works.
thank you. So I've been working on 3 different projects that involve some degree or some level of citizen science, starting with a project in 2013. This is called the COAST Project, or Community Outreach for Accurate Science Translation. So the point is there. People need to understand what science is telling us about the oil spill. That's the rig. We had an artist in the class. So it's a research project funded by the Environmental Protection Agency to a group of scientists, some of whom I work with and some at Skidaway Institute. Their work is on looking at the effect of the oil spill in terms of the dispersant used on blue crabs and blue crab metamorphoses. There we go. So this involved a huge amount of training, because that's what I do, is work with people in small groups. We had room for 20. We selected 25 of the well over 50 people who applied to participate as volunteers in this training program. There was, at 3 years after the oil spill, a huge amount of interest still in what was going on in the Gulf of Mexico as a result of the oil spill. I think it would be the same today. These are some of the volunteers. They're out on one of our research vessels. I believe at the time it was the RV research vessel McElwain. We were out in the Mississippi Sound collecting a trawl of fish and doing water sampling. And then we came back into the classroom and laboratory, and we would look at what we were collecting under the microscope. So the idea is that people should be engaged in scientific activities. A lot of it, though, was lecture and opportunities and different ways of people learning the most recent oil spill science. So we had several scientists who came up and gave presentations about existing knowledge. Most of these people are not ecologists by training, although many of them are naturalists by their interests. So there was an awful lot of background information. And so we had a variety of scientists talking about the Gulf and the life cycle of blue crabs and how does an estuary work, and some fundamental stuff. And then I would come in and hit them with brand new research, because in 2013, we were just getting the first of the really hard, dense research publications on what's going on with the oil spill. So I would talk about specific papers and give them the take-home messages, and they ate it up. And that's good, because in June, they started in maybe March, and in June, they hosted an outreach event in Ocean Springs at the Mary C. O'Keefe Cultural Center. And they had booths where they would show people what plankton looked like and crab larvae. And they would talk to people about where did the oil go and all of these other things that are related to that. And that was a success. We had probably 300 people at that, which was way more than we anticipated. So once again, people are still interested in the oil spill. And some of our participants, as volunteers, were members of the Vietnamese American fishing community. This is a group. This is Mrs. Thao Vu, Mr. Bean Do, and Mrs. Tut Nguyen. And they made a poster. It was in Vietnamese and English, so that if you could go learn from it, even if you didn't speak Vietnamese. But then they talked to members of their community about oil spill research and what we've learned. And this community is extremely harshly affected, both by the oil spill, but also by previously Hurricane Katrina. So these are the people who are out there shrimping and crabbing and oystering. It's a culturally diverse group of people. The group that I worked with was about 2/3 of Vietnamese origin, and those people do not speak a lot of English. It's their second language. All of these people are in a really beleaguered culture. They, as I said, they're threatened, but they just have been stomped by these processes. The hurricane, the oil spill, it's messed up their livelihood, but it's also destroyed their houses in many cases, and they do miss the resource. They're on the water, so not being able to go on the water is meaningful to them. These paintings were done by Carmen Lugo. She's an Ocean Springs artist, and they were done during the outreach day. So it was sort of a participatory art project on a small scale where people would write their thoughts on the oil spill on a sticky note and then slap them up on a wall, and she would read them and then make paintings of them. And these paintings are maybe 18 inches by 24 inches. This one's a little smaller. And these are the things. People are very worried about the wildlife. People are very worried about the dispersant, which is Corexit is the name of the dispersant. So that comes up an awful lot. And one of our comments was from a person who makes shrimp nets, and he's part of that community and has had some serious long-term health effects. Then there's some mental anguish that I think that is shown right here. So this community is stressed. Okay, that's where I left that project in 2013. It's just sort of an introduction to that community. I had another opportunity to do oil spill outreach in 2015 with the Concord Project. That is an oil spill sponsored program from the Gulf of Mexico Research Initiative. And our consortium was related to coastal river-dominated ecosystems, like the Mississippi River Delta region. It's a massive data collection related to understanding the oil spill. These are people on one of the research vessels. We had 2 large research vessels and a whole flotilla of small boats and autonomous sensors out for 2-week periods several times during this grant. And they came up with some interesting things in terms of water chemistry, in terms of physics, and in terms of what was out in the water at any given moment. That's a squid larvae, just so you know, just in case you couldn't figure it out. I don't think it's an octopus, no. I could be wrong. I'm not a biologist. Anyway, we had some very specific outreach goals, and they were to work with this fishing community to understand or help them understand better how the Gulf of Mexico works. But it was intended for the information to go both ways. So scientists would also be listening to learn about the traditional ecological knowledge that the fishermen gained over decades of working and living on the water. So the communication is designed to go both ways. And my goals for them are that they should understand how science works, and that will help them understand how science is used in making decisions about their livelihood, because they're the people who are most directly affected by some of the decisions that are made about natural waters in the state of Mississippi, federal waters, etc. So we want them to understand where these data are, where this information is coming from. All right, so we had training, lots of training. In fact, in this group, we had 4 training sessions over the period of about a year. There was classroom work, and we had to recruit people. And so our recruiting was taking place in both Vietnamese and English, translation in English. I'm sorry, this whole thing is in Vietnamese. The other side is the English translation. The interpretation and translation all the way through was done by Mrs. Vu, my original partner on this project. So that's her right there. So we had these group sessions that took place in the classroom, in the laboratory, and in the field, and they were highly interactive. It was opportunities for us to talk together. If fishermen didn't speak English, it was always facilitated by Mrs. Vu. There were occasionally other people who could facilitate conversations between members of the project team and the fishermen, but we did manage to have pretty robust conversations, and that was a big piece. Another big piece of the training, and this was more one-on-one, was dockside visits. So we would go out to people's boats and teach them again how to use the equipment and talk to them about anything we knew we learned about their resource, but also about how their families are, et cetera, et cetera. And it was a way of getting to know each other and also to keep them engaged so that they would continue to keep coming back to the trainings. Our goal, besides all of the things I've said before, is that these fishermen should collect data for us. And by us, I mean the Concord project. So they were out there with what's called a conductivity temperature depth sensor, and they would throw that in the water, hit a button, it would collect information coming back up, so that up to the surface, so that we could get information about how temperature and salinity change with depth in the Mississippi Sound and the Gulf of Mexico. So we got 109 depth profiles from 10 fishermen over the course of about a year. And they were mostly here. Mostly the people were not out shrimping at that time. And they collected data all over the Mississippi Sound. And these data were used to validate Concord models of how water flows, so that in the event of a future oil spill, we would have a better understanding of how the oil works as it comes ashore. What's it going to do? Where's it going to go? Because our models were not very good at predicting what actually happened. So this was the citizen science component of it. And we also had a social science component. So Candace Bright, who was at University of Southern Mississippi at the time, she's now at East Tennessee State University, worked with our 45 citizen scientists. 18 of them gave interviews. If you'll notice, only 10 fishermen provided the profiles, but there were 45 who were actually collecting other types of water quality and descriptive data. Her interest was in understanding what the effect of participation had on understanding oil spill science and their level of trust in oil spill science. And so she did that by interviewing these people and building themes, and ultimately described them as a circular process, starting with building a relationship, moving through transparency, trust in science, and scientific literacy. So the first step, Concord promotes relationships between fisher folks and scientists. And that's the primary thing, is that by being in each other's presence as much as we were, we built relationships that continue to today. If I see people in the store, big hugs, how's it going? We don't touch now because of coronavirus, but we would otherwise. And some of the quotes that came out in terms of the Concord project on developing a better relationship with scientists. So the first thing is built on relationships. But if you have these relationships, it improves the participants' understanding of the transparency. And this is really important. I haven't made this point before, but how the fishermen perceived us differs from how the fishermen perceive scientists in regulatory agencies, as it turns out. So the project is giving us the opportunity to compare the data that they collect with what our USM scientists were collecting, and the regulatory agencies just don't do that. So transparency has been a huge problem, and we've just recognized it here and talked about how that relates to trust in science. And transparency improves trust in science, and the citizen scientists began to get a better understanding of how science works, and that's because you have to trust. That opens your mind to make it possible to understand the science. So I can't go shrimping right now, but I've been collecting data. And it's a way to continue his education by learning about the different bodies of water. So this allows them something to do while they're having a hard time with their resource anyway. So this project, completely separate from the intentions of the project, actually gave the citizen scientists a way to be part of their resource while they couldn't be. All right, so the trust in science improves future relationships. It's a circular pattern. We have lives on the water. The scientists don't have that. So they're contributing. Concord has made that possible, and they want to keep going, right? So that's the take-home message, is that the citizen scientists have increased trust in how science works. They understand science better, and they want to keep going. So we didn't stop there. That was the end of Concord. And then one of the quotes as part of Concord is that maybe there are other gaps in the scientific, the scientific community, but mostly in the scientific body of knowledge is what he's talking about, I assume, that we may not be aware of. So maybe we don't know something about the resource, about the Gulf of Mexico, that fishermen might know because they're always out on the water. That is another quote from the fishermen. And so we kept moving. So that's one of our guys with the sensor. Our next project, Building Bridges to Fishing Communities, was sponsored by the National Academies of Science. In this case, the Fisher folks were partnering with us. They were leading the research. They were very interested in oyster reefs. That subject has blown up in the past 5 or so years. It's very important to the people who are living out there that the oyster reefs have been degraded so much. And these guys, our community, were very interested in the presence of PAHs, which are polyaromatic hydrocarbons, and they're a contaminant from oil, potentially from the oil spill. They could also come, that PAHs can also come from other sources, boats, etc. But that's what we were looking for, and the fishermen were in charge. It was their grant. So in this case, the project goals were to monitor the reef and collect data for a very real community need. And it was a way also of getting a larger scale involvement with the community now that we know that we can make it happen. And so they would go out and collect, first we were trained. We got together, we went to the toxicology lab, we hung out in classrooms and learned from toxicologists. We did more water sampling, and people are more involved. Notice they're not wearing their safety gear, but I can show that to an adult USM community. We would not do that with kids, but they are really getting a kick out of this. They really enjoy the training, and sometimes more engaged than others, but getting it. Field and lab activities. This was more dockside visits, and for those dockside visits, they would go out for a day and go to several different reefs, collect 12 oysters from each reef, bring them back to the laboratory, process the tissue, process the shell, process the sediment. And when I say that, I mean grind up the tissue in the shell so that the analysis can be done for the polyaromatic hydrocarbons. That's all being done by the fishermen. And we got data. We got a good data. Data came from oysters on 6 reefs. And one of the maps that one of the fishermen made shows the green where live oysters were found, yellow where oyster shell was found, and red where nothing was found. And so there's a significant amount of red, there's a whole lot of yellow, and there's some still green in a couple of different parts of the coast. The interesting part about this is that when a representative from the Department of Marine Resources, the chief scientist of the Department of Marine Resources, came to a workshop with this community, he was very interested to see the data and found it to be consistent with data that they collect using completely different data collection methods. So, we thought that was important in showing that citizen scientists can collect good data. reliable data. And we, in the social science aspect, I'm not going to talk anymore about the social science data that we collected for this project, but it reinforced what we learned from the Concord project. I believe the next is the however. Okay. However, there was a certain erosion of trust in this project. The Fisher folks had more ownership of it. They had the final call on some of the decisions that were made. And at the beginning of the project, a suggestion was made to change some of the methods for the project. And that set us off to a bad tone in some of the ways that the project worked in terms of collecting data. So the researcher offered an alternative method, it was rejected, and it initiated a loss of trust in the scientists. This is my interpretation, please. Loss of trust in the scientists, which led to a rejection of future advice based on very standard protocols. So there was that. That was very disappointing. It does not negate the information I gave you before. I'm not giving you any bad data. It's part of another part of the data. And there's a lot to consider here. In part, there are cultural challenges, there are language access issues. And one thing I think is really important is that in one case, in the case of the fishermen and the scientists, the fishermen, no matter how dedicated your scientists are, they're not living on the water. Their sole income is not the fishing resource or the fishery. And so having that interaction between the two put a lot of weight into one decision. So that was one challenge. And then halfway through the collection effort, all the oysters died when the Bonnie Carey spillway was open and released fresh water into the Mississippi Sound. So all of these areas right here that are green, they're not green anymore. Yep, they're not green anymore, making sure that's not Texas or something. Because the Mississippi River was open, the Bonnie Carey spillway allowed water to come through in this direction. And you could watch the salinity changing sequentially, day by day, week by week, and the oysters mortality was increasing all through the summer, and ultimately they all died. Okay, so that was a challenge. That was a big challenge. We did have some successes, and I feel weird saying that right after saying that their whole fishery died. It will have to be restored. We did build trust in this one small fishing community, and the trust is based on relationship, and the relationship still exists. There was a big mess initially, in this last project, but the citizen scientists have improved science literacy, and they also still express great interest in future development of the relationship with the research and, oddly enough, regulatory communities. Not a lot in this case, but there are some glimmers that there might be a little bit more willingness to sit at the table. So the trust is not really there, but we've made friends in this case from the research and fishing community. What I think is really important, as I think is always important in terms of teaching, is that the fishing community took complete ownership of their scientific process. They started working with me in 2013 as participants in research outreach. They continued working with me as citizen scientists collecting data in the second project, and they became a leader in the research in this most recent third project. And the data collection efforts provided reliable data. Shudong is actually the name of the student who used the data to validate Concord models. So those are, that's how the data were used in the Concord project. And then the oyster map is actually been given to DMR for their purposes. In conclusion, there's a couple of slides here, but this is the conclusion. So relationship building promotes effective outreach. And stakeholders can collect worthy data. I think that's the two most important take-home messages. I think this is really, really the most important message at all for the future, is that communication is what went wrong in our problem with the fishermen. And we can figure out ways to broaden access across the community, but I think that's the most important. How's it relevant? The Bonnie Carey Spillway might be opened again, although not likely this year. And maybe there's some other public trust in science issues we have to consider. That is all. Questions?
There's a lot of questions I have.
Yeah.
I think we need to push for and allow the river to go down the Chapel.
That is a long conversation I would enjoy having with you.
But to get back to our topic, why, you can learn so much from informal observations. Like we could tell when an El Nino happened 500 years from a captain's log.
Yes.
And that captain did not know that he was helping somebody.
Yes.
And so, why are the scientists given trouble when you have a willing public?
What do you mean? Oh,
Like,
I don't
They
actually.
said, well, they don't do it properly.
Oh, when I say that, okay, so that's my interpretation of what I saw happening after the oil spill, is that a reporter would go to a scientist and the scientist knows X about blue crabs. X, just X. And they would be asked about the whole alphabet related to blue crabs. And scientists can't do anything with that any better than anybody can. And there's only 30 seconds and there's a camera and a microphone right there. So it's a matter of it's difficult because it's like framing your message is really important, but that to some people would sound like you're creating a story and that could become misinformation. So you have to be really careful, but you also have to be able to tell people with not too many words what they need to know. That's one piece. The other piece is we just didn't know the answer to the questions. That's it. We didn't know the answer to the questions, and it's very hard to say, I don't know, and stop.
Yes.
So that is a huge piece.
Just send Dr. Vernon Asper out.
What's that?
Dr. Vernon Asper.
Uh-huh.
He's usually, when he's a public figure.
Yeah, he did a lot of it.
Yeah.
A lot of scientists got a lot of airtime. And I got to talk to him, so I felt really lucky. I got to do, I'm a scientist by training, and the oil spill was interesting in a lot of ways. And for me, it was really very intellectually stimulating to get to read a body of literature as it was coming out. Because on day one, there was no information about the Deepwater Horizon oil spill. And today there are over 1,000 papers specifically resulting from Deepwater Horizon oil spill and the many, many millions of dollars of investment that have been made in Gulf of Mexico research science.
Jessie, you can hear me?
Some of the scientists that helped you with the training, as Joe's picture. And
Yes.
So sort of from a logistics standpoint, how you put together.
Type it out.
Yeah.
How did you pick your team members and how did that work?
So I think this is, touch the screen, Brent. Good. Okay, so it stayed in the same place. That's really important, and that's really not easy. It was very difficult to get the fishing community involved. The scientific community was already involved. They called me because they have interests in communicating the broader impacts of their research. Okay, that's just what granting agencies want scientists to be able to do. Having said that, it's difficult for someone who's spending their life answering a question, and usually a pretty specific question, to come out and talk about broader questions with members of the public. many scientists like Vernon Asper really enjoy that opportunity to do that. And I've been lucky to work with a bunch of scientists. Actually, I'm going to go. Okay, so I have scientists from Mississippi State University. The EPA actually did have a scientist. These 6 universities and Skidaway Institute. So I've gotten to work with dozens of scientists in communicating work on the oil spill. And it's not, if I have dozens of scientists on Concord, most of the people who were interested in interacting were early career scientists or somebody who had already expressed an interest in doing education and outreach. And those people are pretty easy to find. It's very nice to find them. They're fun to work with. The early career scientists can learn while they're learning science. They can learn how to make those connections while they're learning how to do science. And I think that there are ways to reach those early career scientists that are worth talking about. I had a training day out on an island once and got the early career scientists to go out with me, and we did some water quality sampling and profiled some elevations on the beach. And so if you give them a good reason to do it, you can find ways to get people to communicate. Scientists want to be able to do it, but the training in how to communicate is very limited. And there are some people who are getting very good at it. Alan Alda, oddly enough, uses improv and teaches people teaches scientists improv techniques. And there's a lot of ways of doing it. So you have to do research on ways that will work for your particular set of scientists and recruiting scientists. Did that help?
Mm-hmm. It sounds like it's very self-motivating among the community because that is their domain and they want more knowledge of their domain.
The Fishers?
Right.
Yeah.
So it seems like it would be self-reinforcing that they would want to keep data.
Yeah, I think that's absolutely true. That is the purpose of this presentation and this set of projects. I don't think it's the only group, so it is more general, as you're saying. And I think there are a lot of groups that are interested in being part of that effort. And in fact, that's what I spend my life trying to find money to do, is engage more audiences in this kind of science engagement.
It sounds like a little connection with service learning. And it's very difficult to inspire faculty to go out in the community because they want to hear from you.
You mean the community wants to hear from scientists?
They do. They really.
I think you're absolutely correct. I know it's a challenge to get scientists out, but in my experience, I mean, there's some scientists, research scientists, who just don't want to do it. But the vast majority of people I've talked to recognize the value, and if they are given ways to do it, they'll take that opportunity. And it has to be something that they can work into their schedule. So I have people who are always available. And then I have people who I'm just like, okay, I've wedged out this little space. What can we do with your time in that little space? So, I mean, it's just a question of how much the scientists are interested, but I think the scientists are largely interested.
You're making me think we should develop a science communication class here in the center.
You should, I would take it.
This is a global issue of how do we, because a lot of us PhDs sit around talking to other PhDs, and that's great. We understand each other's language, but communicating things to the public in a way that's well received, that's understood, and that's important to them, that's meaningful for their space, for their locale. And these are very hard things to do.
Yeah.
And they're out of most of our toolboxes. And so, yeah, a science communications course involving various scientists on campus and people who Vernon Asper and other people who become good at this, I think could be really useful for the entire university, community.
Like I said, I would take that class. I might be able to teach one lesson of that class, but I would not necessarily feel confident doing so, but I do think that the type of work that I really do the type of work that I do really does lend itself to giving people a way to learn and to giving scientists a way to teach. That brings up a really important point that I maybe didn't make strongly enough. Scientists should be learning too. Communication requires listening. Part of that is that traditional ecological knowledge is knowledge. It's not the same knowledge, but it has a place, as you were saying, the logs from hundreds of years ago, the matron aunt's diary from Britain in 1850 is telling us what the butterflies were doing then, which is not what the butterflies are doing now, which is one of the ways we know that climate is changing. So citizen science is a big deal. And scientists can learn from citizen scientists if we can all listen. So that's a goal for me, is that the scientists should be more engaged.
Sure. I think we've got a question here, or at least a comment to yes to the science communication class, yes to the science communication course. And it would just be cool to have different faculty and faculty partners doing this kind of all together. So are there any other questions from the group before we say thank you to Jessie? All right, thank you so much.
Thank you very much. I really appreciated your attention. And